So here's an interesting problem where they are asking us to calculate or determine what we should read if we use an ohm meter and we measure between points A and D. And the interesting thing here is that they have a switch right here that they say is closed at t equal to 3. So they're asking us, if we were to come back at t equal 1 and take a measurement and then come back at t equal 4, what would be the two different measurements we should receive? And they should be different because the switch will be shut in between those two times. So basically it's an equivalent resistant calculation that we'll do 2 times to try to figure this out. So let's look at this. If we examine the circuit at t equal 1, that's before t equal 3, then the switch will be open. And so that being the case, it would be as if this whole connection was just not even here. So this is an open circuit, so we don't have to consider this. And so this is what we're left with. So now let's examine this circuit and see what we come up with. So the first thing we see is that this circuit, or this resistor and this resistor, are in series. So we should be able to add those together. Just simple addition, and so we do 3 plus 4 is 7. So 3 plus 4 is 7. That means we can replace these two resistors with just one resistor. And to do that, we'll just get rid of this guy, and we'll change this value. And we said that this would just be 7. So close that, and now this is just 7. So now we take a look and see that we have this in parallel with this. So the 2 ohm is in parallel with the 7 ohm. And so we can come up with a single resistor to replace those, which would be 2 in parallel with 7. And to calculate that, that's 2 times 7 over 2 plus 7. And so that will give us 14 over 9. So 14 over 9. So that means we can replace all of that with one resistor. So that means we won't need any of this part of the circuit anymore. So let's go ahead and wipe that out. And don't have to consider that anymore. And the new value here is going to be 14 over 9. So now we see, looking at this, we now have, again, we're going from A to D. Now we just have 2 resistors in series again. So we should be able to reduce that down to 1 resistor by adding those together. And so this will be our equivalent resistance. And so we'll just write that as Req is what we should measure. And so this will be the resistance AD at t equals 1 second. And so that'll be 1 plus 14 over 9. And when we calculate that out, it should be 23 over 9 ohms. Okay, so that's the first part of the problem. So before the switch closes, if we measure between these 2 points with an ohm meter, we should get 23 over 9, or whatever the decimal equivalent of that is, ohms. Okay, so now let's go back and look at our circuit again. And now we're going to say the switch is closed. At t equal 4, the switch is definitely closed. So that means that's just a shorted connection across there. So we can draw that as such. So let's do that. That means all of this would be gone. And then we would just show a connection here. So when we do that, the first thing we should notice then is that this resistor is shorted out. It will never see any current go through it. So for all practical purposes, it has no bearing on our circuit. So therefore, we can just eliminate that. So let's do that. So this is all gone. Once that switch closes, this is no longer a part of our circuit. So now as we look at our circuit, we now see that these two resistors, 2 and 3, are connected in parallel. They have the same input and output. So we can calculate that, a replacement resistance for that. So it'd be 2 in parallel with 3. So that is 2 times 3 over 2 plus 3. So that'll be 6/5. So let's go back and replace that then. So now we can replace those two with just one resistor. So now this is no longer needed. All of this is gone. Right here, and then this value is now 6/5. So now we see that we, again, as before, just have two resistors in series. So then if we add those up, that should give us our equivalent resistance. So we'll write this as equivalent resistance, which is equal to RAD. Again, this is for T equal to 4. So this will be 1 plus 6/5, which when we add that up or calculate that, it's 11/5 ohms. So there you go. So depending on which time you've make the measurement, if it's before the switch closes, you should get 23/9 ohms. If it's after the switch closes, it should be 11/5 ohms.